What is an ICE chart? What is an equilibrium constant? How are the two related? All these questions that I'm going to answer in this video. So, ICE, 3 letters that stand for 3 words. I is initial. C is change. And E is equilibrium. So, what does this have to do with chemistry? So there are 3 stages in a reaction that reaches equilibrium. There's the initial, which is the initial concentration of all the species. There's the change, which is the amount of concentration either gained or lost. And then there's the equilibrium, which is the sum of the two. So actually, I plus C equals E. That's the formula. Initial plus the change is equal to the concentration at equilibrium. So the way this is usually represented is within a chart. So if we have a generic reaction like A plus B equals C, or it's not how you do it, it's like this equals C, then you have that on the top part. Then on the left side you have I, C, then E. And then here you would put a concentration, here you would put a concentration, here you would put a concentration. And it would look like this. Then you would add these two and it would go like that. So now what is equilibrium constant? So Keq, the formula is concentration of products over concentration of reactants. And in this generic reaction, it would be C over concentration of C over concentration of A times concentration of B. So you multiply the species on the same side. But let's say it gave us, instead of C, we had 2C. And when you have a coefficient on a species, then you actually put that as an exponent in this equation. And this will give you a number that won't have a unit. So now let's jump into a question. Consider the reaction 2NOG plus Cl2G equals 2NOClG. A mixture of consisting of 2.00 moles of NO and 2.00 moles of Cl2 is placed in a 5.0 liter container. When the system reaches equilibrium, 30% of the original NO is used up. Calculate the equilibrium constant of the reaction. So you should always start with drawing an ice chart. So we can start with the equation, chemical equation, 2NO plus Cl2. You don't need to put the phases in this one here. It's just a waste of time. Equals 2NOCl. Then on the left we have I, C, and E. So we're not given any concentrations in this question, but we can find them because we're given moles and liters, and concentration M equals moles per liter. So that means that, let's say, the concentration of NO equals number of moles of NO, which is 2.00 moles, divided by the size of the container, which is 5.0 liters, and that equals 0.4022. 2 sig figs molar. And since we also know that Cl2 has the same amount of moles in the same container, and it has the same concentration. So they're both 0.40 molar, and this is at initial. 0.40 molar. And also, if there's a species in the reaction that isn't mentioned in the question, like at the start we're given NO and Cl2, but says nothing about NaCl, then that means this has no concentration. So next, we're given this piece of information. 30% of the original NO is used up. And this is our change. But first we need to calculate what 30% of the original NO is. So 30% is the same as 0.3 times the original NO concentration, which is NO 0.40 molar equals 0.12 molar. And it is used up, so you subtract 0.12 molar. And then from this we can find what the equilibrium concentration is, and it's 0.28 molar. So now, if we're given change for one of the species, we can also find the change for all the other species. And it is in this stage the coefficients come into play. Each change for each species is proportional to its coefficient in the reaction. So since we have 2 NO and 1 Cl2, that means Cl2 will have half the concentration change as NO. So that's minus 0.06 molar. And that gives us 0.34 molar. And then for the NaCl, it has the same coefficient as NO, so it has the same change. But since it's on the opposite side from NO, which has a negative change, this one should have a positive change. So if one side is losing concentration, that means the other side is gaining concentration. So that means the equilibrium 0 plus 0.12 is 0.12 molar. Now since we have our ice chart filled out, we can now find the Keq, and that is the concentration of products over concentration of reactants. And the product is 0.12 molar. And since there's a coefficient of 2 in the chemical equation, then we square this value. Then our reactants is NO, which has 0.28, 0.28 with a coefficient of 2, so it's squared. And then Cl2, which is 0.34 molar. And then from this, we just put in our calculator 0.12 exponent 2 divided by 0.28 exponent 2, and divided by 0.34. And to 2 sig figs, that gives us 0.54. And that's the answer to the question, what is the equilibrium constant? And that's all. Thank you for watching.